Hello everyone, welcome to today's lesson on squares and roots. So last time, we worked a lot with factor trees and finding out the greatest common factor and the lowest common multiple. But this time, or like I said last time, prime factors are the building blocks of all numbers. So we can actually use prime factors to figure out the square roots of numbers as well. Pretty cool stuff. So a quick review of squares and roots. What's the area of a square? It's just length times width. So in this case, 5 times 5, so 25 units squared. Right, that's it. So a square of a number is essentially just the area of a square with that edge length. How about a volume? We know that's length times width times height. In this case, 3 sixths. Oops. 216. So this is why we refer to those numbers as squared and cubed. Right. Whenever we square a number, we essentially just imagine that number being the edge of a square and then find the area of that square. Same with cubes. If we cube a number, that means it's just the number multiplied by itself 3 times, because that's a volume of a cube of that length. And now a perfect square is the result of that. So that's the area of a square. So say 25, right? 25 can be expressed as 5 times 5. The square root of that is just the side length of that square. So if we have a square of the area 25, unit squared, then the side length of that is the square root of 25, which is 5. Perfect cube, similar idea, but for volume and cubes. So that's the side length of a cube. Right, so for example, we got a square here. The area of that is just 7 times 7, or 7 squared. Hence where the name came from. So 49 units squared. And of course the side length of that, if we are not given all this, but we are given that the area is 49, the length of the square is just square root of 49, which is 7 units. Right, so same as decimals, right? Because no matter what decimals or numbers we have, as long as it can be used to find the area of a square, right, that number is a perfect number. So technically, or not technically, actually, 10.24 is a perfect number. And notice how it's any number. It's not limited to just integers. Decimals are okay too. We do not discriminate against decimals when it comes to perfect numbers. Right? How about negative? Right? Don't worry about this image. This image is illegal, but for the purpose of this illustration, right, if you can imagine negative 2 side length, that's negative 8 units cubed. Let's remember, 2 negatives make it positive, 1 positive and negative make it negative. So the side length is the cube root of negative 8, which is negative 2. So yes, negative numbers and also decimals, they're both allowed to be perfect squares. Okay, so how do we find them? The square roots. Let's say the square root of 324. Right, so we can always start with a factor tree. That's divisible by 2. That's also divisible by 2. 81, we know it's 9 times 9. 81 comes up a lot, huh? Okay, so right here, we have those prime factors. So now we know square root of a number is just the same number multiplied by itself twice. So what we can do now, right, is we can split into 2 equal groups of factors. right? Because if we can split all those factors into two even numbers or two even equal groups, then that just means we have a number times a number, the same number. Right? So let's rearrange it so that our two groups here both have 1, 2, and 2 3s. Right? Because you can think of it as that's our first group, second group. Right? That's how we can rearrange those prime factors so that it's two of the same groups together. And of course, 2 times 3 times 3 is 18. Right? And from there, we can see that 324 is just 18 times 18. So the square root of 324 is 18. Okay, that's it. So because as you can see, we can do pretty efficiently. We just have to clump them into groups. Okay, let's try it. 4 for 1. Divisible by 3. That number is also divisible by 3. 49 to 7 times 7. Okay, we can again scoosh them into even groups, equal groups. Right. So 21 times 21, aka square root of 441 is 21. Okay, let's try this next one here. 121. Alright, for this one, we actually have to try out a lot of factors to reach 11. That's not divisible by 2, 3, 4, 5, 6, all the way up to 11. So from there, luckily, it actually 121 divided by 11 is also 11. So root 121 is just 11. Right, and now to save some time on this, right, we know for sure it's not divisible by 2 because it's not even. If a number is not divisible by 2, it is not divisible by any of the even factors. So if it's not divisible by 2, it's not divisible by 4, 6, 8, and so on and so forth. Okay, but this one is divisible by 2 though. 1764. Okay, divisible by 2. We got 882. Divisible by 2. Okay, that one's divisible by 3. That's divisible by 7. Okay, and just like that. Okay. Again, I know that's divisible by 7 right here because we have a 14 here and a 7. Right, but again, if we just try out every single factor, we can see that's also divisible by 3. So it's 7, 7. Okay, and here from here, I'm gonna skip some steps here. Right, we see have 2 2s, 2 3s, and then 2 7s. Alright, we can start grouping them right away. We got a 2, a 3, and a 7, and then a 2, a 3, and a 7. Right? Look at that, 42. Right, we would have to try out every single number here in the calculator, but we can use prime factorization to figure it out quickly. Same with the same logic, we can do cube roots as well. That's divisible by 3, or actually also 2. There you go. I know right away it's divisible by 3 because a quick trick you can use is that if all the digits of a number adds up to a number that's divisible by 3, then the whole thing is divisible by 3. Right here we have 2, 1, and 6. Add up is 9. We know 9 is divisible by 3, so 2016 is also divisible by 3. But we can just do 2 for now, because let's be honest, the end result does not matter. 64, 6 times 9. Right, so 216 is like that. If the cube roots, we need 2 equal groups, right? Because it's a number times a number. With square roots, it's the same number multiplied by itself 2 times. Hence, we need 2 groups. With cube roots now, that means it's a number multiplied by itself 3 times. So we will need 3 even groups, which as you can see is a 2 and a 3. Right, we got 2, 3. That's group number 1, 2, 3. Group number 2, 2, 3, group number 3. And as we can see, 6 times 6 times 6. Right, and of course we can group them already here in our factor tree as well. Right, so cube root of that must be 6. Okay, here's the fun one, 729. Divisible by 3. 3 again. 9, like I said, 81 keeps coming up for all my factor trees for some reason. Okay, so we can see here that it's just 3 multiplied by itself 6 times. So, as you can imagine, we can very easily just kind of split them into 3 groups. Right? But we also notice here that we don't actually have to split them into 3 groups, right? We can also realize that, hey, we can actually split them into 2 groups as well. Right, so the square root of 729 is 27, whereas the cube root of 79 is 9. Right, so you can see here, depending on how many groups you clump up, you can actually see the different roots. Of course, you have 4th roots, right? The same idea, 4 groups. Okay, how about 1,000 here? 1,000 is just 100 times 10. Right, and to be honest, from here, we don't even have to keep going, right? We see that 1,000 is just 10 times 10 times 10. So that is literally just equals to 10. The cube root of it. Right? Even if you try and factor it, and we see 3 groups of 2 times 5. Okay, word problem. I have a pretty cool bubble tea drink mix, which has a volume of this. What's the surface area? Alright, so remember surface area. That's the area of all the sides of the shape. So you can kind of imagine this cube here, and then we split it open, right? Because a cube has 6 sides, right? 1, 2, 3. And remember, we have 3 sides at the back there. Right, so it's 6 sides in total. Because you can imagine we can open it up like this with 6 sides of squares. Which means that if we can just find the length of one edge, right, then we can find the surface area. Okay, so let's check it out. 343. Yeah, it looks like it's divisible by 3, but it's not, right? It's not divisible by 2 because it's not even. So not 2 and not 3. Because it's not divisible by 2, it's not divisible by 4, 6, 8, and all the even ones. Not divisible by 5. But with 7, luckily, it's just 7 times 49. So the cube root of 343 is 7. That's the side length. Right, notice here it's the cube root, not square root, because we're talking about a cube with this volume. Now we know the side length of this cube is 7 centimeters. And now this cube is made up of 6 squares, each with a length of 7. So this means the surface area is just 6 times the area of one of the cube faces, right? Because if we find the area of one face, we just multiply it by 6, and that's the total surface area. And the area of one face is just 7 squared. Multiply that out. And that's it. Right? Just like that. So that's how we find roots. Right? All we have to do is find a prime factorization and then put them into clumps. Either 2 clumps for square roots, or 3 clumps for cube roots. Or like, I don't know, 15 clumps for 15th root. But let's gonna be honest, I will never give you that because that sounds like a waste of time for me to for you to mark, right? For me to mark and for you to do. But the basic idea is to find roots, you just split them into equal groups. Okay, but without being said, good luck practicing.